Well, we're back here at the Cave of Science, and we're looking at Unit 4, Worksheet 4, and we're looking at problems 6, 7, and 8. Alright, so let's look at, we're going to call this problem 6. So we got a couple compounds of hydrogen and oxygen, and compound 1 contains 15 grams of hydrogen and 120 grams of oxygen. Compound 2 contains 2 grams of hydrogen and 32 grams of oxygen. Determine the ratio of the mass of oxygen to the mass of hydrogen. So we're looking at the ratio of oxygen to hydrogen. So let's go compound 1. So compound 1, and again we want oxygen to hydrogen. So we got 120 of oxygen to 15 of hydrogen. So if we go ahead and divide that particular ratio out, we'll find that that is a ratio of 8. And let's go ahead and do compound 2. So compound 2, I guess we'll use the Roman numerals. We've got 32 grams of oxygen. So we can go ahead and 32 of oxygen to, let's see, 2 grams of hydrogen. So 32 to 2 of hydrogen. Well, if we go ahead and do 32 divided by 2, that's pretty obvious. That's 16. Well, we can see compound 2 is 2 times that of compound 1. Yeah, I should have made that a Roman numeral, but I didn't. So we've got twice as much oxygen in 2 as we do 1. Alright, so let's see what we got here. Oh, I got the wrong sheet. Hang on a second here. What is significant about these mass ratios? Again, as we talked about, compound 2 is twice that of compound 1 for oxygen. So no biggie there. If compound 1 is water, and water is H2O, what could the formula of compound 2 be? Well, we got to leave the hydrogen alone because we're only looking at the oxygen. So we're saying that if compound 1 is water, 2 hydrogens to 1 oxygen, what's compound 2? Well, we got to leave the hydrogens alone. Well, we're saying in compound 2 that oxygen is 2 times that of 1. So it's going to be H2O2. So that is going to be the answer for 6D. Oh, let's see what we got here on problem number 7. Oops. I guess I better pull that down a little bit. Oh, excuse me. Alright, so we got nitrogen and oxygen combined to form, I'm going to get rid of the sheet. Various compounds. The following data were collected for 3 different compounds of nitrogen and oxygen. So as we're looking at that, the mass of nitrogen that combines with 1 gram of oxygen. So really we're just looking at the nitrogen here. Well, additional evidence shows that the formula of compound B is NO. So we can put that right in there. Alright, so that's NO. Well, we can see from this that A looks like the amount of nitrogen should be twice as much. So we can see that it's going to be twice as much. So if that's going to be NO, if this is NO and nitrogen's twice as much, this is going to be N2O, because we got twice as much nitrogen. And again, we are looking at the nitrogen. Well, let's look at number 3, or letter C here. So again, we're looking at nitrogen. So it looks like nitrogen is 1/2 of the oxygen. It's like the nitrogen is 1/2 of the oxygen. Well, we can't write 1/2 O. That's just, you just like to work in whole numbers here. So how do we get rid of a half? Let's multiply this by 2 and that by 2. So this will be N2, NO2. 1/2 times 2 is 1. Again, 1's always understood to be there. And then 2 times 1 is 2. So we've got that particular formula. I kind of got ahead of the game a little bit here. They wanted some diagrams. So in A, we're saying it's N2O, and then B is NO, and then in C we got 2 oxygens on there. So we can go ahead and sketch this out. Let's go with compound A, compound B, and compound C. So we got B, we know is 1:1. Let's just, for the sake of discussion, let's call this N, and we can call this O. That's a 1:1. That one's pretty easy on B. On 2, we're saying we got 2 nitrogen. Yeah, let's just call this nitrogen and this oxygen. So this one's NO, this one's N2O. Well, this one we know is NO2, so we got to make it the reverse here. So we can go ahead and put in our nitrogen, and we've got 2 oxygens to go with it. So we have that going on there. Oh, it says explain how the examples in 6 and 7 help illustrate the law of multiple proportions. And again, you're always looking at whole number ratios. So for number 8, you always want to look for whole number ratios. I think as you whoops, let's see, I should push that up a little bit. Number 8, you're looking at whole number ratios. I think when you're working at these, I think kind of the key is to see what's being compared to what here. And as you go through these, you start to get kind of a feel for what's happening with these. Again, this is a good practice for these, and as we go through these, you'll get more and more familiar. So this is problems 6, 7, and 8 on Unit 4, or Worksheet 4.